Hello, it's Dumplet here. Here's an item on number theory. A to the fourth minus 3a squared plus 9 is a prime number. Find the value of a that is a positive integer. Credits to the Art of Problem Solving community for this item. As usual, pause this video if you'd like to give this item a try. But if you're done, let us dive into solution. Alright, so a typical question, we have a given expression to be prime. Here we have a fourth degree polynomial expression, and our first instinct is to hopefully we can factor this one, because, well, if we can factor this one, then we can assign a factor to be 1. So this polynomial is not really obvious on how to factor, but we can do a very well-known trick. We can try to complete the square, and we can factor it that way. Now there's a lot of ways to complete the square. I'll show you guys two ways to complete the square, but obviously there's only going to be one possible factoring here. But let us try to do some motivations here. Now we can talk about the given terms. We have a to the fourth, 3a squared, and 9. So because a to the fourth and 9, they are already perfect squares, it would be easier to do the completing the square with these two terms. So, but we would know that, well, if we want to have a to the fourth and 9 to become part of a perfect square trinomial, it's going to be either a to the fourth, well, then plus 9, and the middle term, it's either going to be a plus 6a squared or a minus 6a squared. All right, so those are the two ways to to complete the square. Now, since we want to make this and this and the resulting term to be equal, we have to consider that, all right, apparently in the first one we have to do minus 9a squared, and then the second one we have to do plus 3a squared. But we can easily see here that, well, the second one will not work because, yes, this is a perfect square, but we're adding 3a squared. That's not really a difference of two squares that we want, so we will disregard this one. But we can see here that in the first one, we have a perfect square here, right? That's going to be a squared plus 3, the square of a squared plus 3. And then we're subtracting, that's good, we're subtracting 9a squared, and that's going to be equal to the square of 3a. So that's very nice because we now have a difference of squares. All right, now let's focus on this one. We just have to factor this one. That's a difference of two squares, so we're going to do a squared plus 3 plus 3a. Right, let's multiply this by a squared plus 3 minus 3a. And we can kind of arrange the terms a little bit, but it's going to be, it's going to be a squared. It's going to be a squared plus 3a plus 3. That's going to be the bigger factor. Again, a is a positive integer. And a squared minus 3a plus 3. Now, this is going to be bigger than this one, and that's the reason why we have to make sure that the smaller factor must be 1. All right? The smaller factor must be 1, because if the smaller factor was not equal to 1, then the other factor would be greater than 1 as well, which is not going to make it prime because it's already factored form. So we have to make sure that this term, the a squared plus 3 minus 3a, is equal to 1. It's going to be a simple quadratic equation. So a squared plus 3 minus 3a, that's going to be equal to 1. Now from here we're going to get a squared minus 3a plus 2 is equal to 0. And then we can factor the given quadratic as a minus 2 times a minus 1 be equal to 0. And we can get a equals 2 from the first factor and a equals 1 from the second factor. Now, yes, we have two values for a, but we only consider that, all right, one of the factors must be 1. We haven't really made sure that the given expression is going to be a prime number. But let's try to check things here. If a equals 1, let's try to substitute things here. So if a equals 1, 1 to the fourth is 1. 3a squared becomes 3, so minus 3, then plus 9. And that's going to give us 7, and 7 is a prime number. So there we go, 7 is prime. So a equals 1 is possible. All right, let's try a equals 2. Now if a equals 2 here, a to the fourth, so 2 to the fourth is 16. 3a squared is 3 times 2 squared, so that's 3 times 4, so so minus 12, and then we have a plus 9. 16 minus 12 plus 9, that's going to be equal to 13, and yes, it is a perfect square. Sorry, it is a prime number. So, alright, we have two possible values of a that we got, a equals 1 or a equals 2. Apparently both of them give us a prime number as a result, so there we go. We have two possible values for the positive integer a equals 1 and a equals 2, and this will be our final answer. Hopefully you guys learned something new from this video, and I'll see you in the next one. Bye bye!